Hello and welcome back. So far we have actually loaded the data set and then splitted the data into train test and then did some exploratory data analysis, right, with using the describe method and found a quality issue and fixed it. Okay, so found a quality issue in the lines of code where negative numbers are there, should not be there, and we replaced them with 0. Okay, and this is a business scenario, right? You know that the lines of code should not be 0. That's a business knowledge. Using that, you are actually you have fixed the data. Now let us see whether there are nulls or not, because the machine learning algorithms will not accept nulls or they will not work with nulls. So we need to replace the nulls or remove the rows or columns which have got nulls. Generally, we will never remove the column because the data is so precious. If you try to remove a column, right, only when it has got more than 75% or maybe 80% of the nulls, 80% of the data is nulls. Generally we don't remove rows because maybe one column has got null but the other columns have got data, right? So the data is very precious in understanding the pattern, right? You are using the input variables and the output variable and trying to understand the pattern or trying to derive an equation which is more generalized. So if you have more number of records, the understanding will be more. So instead of removing the records or columns, we'll try to impute them or replace them with some appropriate values. The imputation can be done based on the business logic or based on statistical data analysis. So here, in this particular example, we are doing statistical data analysis and trying to impute. So when you do statistical data analysis, right, you actually try to look for normal distribution in the columns. If they have normal distribution, right, especially the numerical variables, they have or categorical also, they have normal distribution, you can take mean and replace because most of the data is going to be, the 68% of the data is going to be close to mean. So let us look at it. We haven't found any normally distributed columns in this particular data set, but let us look at and how we have fixed it. So first of all, to find out whether any column has got null or not, the train set dot is null will give you falses and truths in total thing. If you say dot any, right, it will give you the column names where you have got null. So qualification has got some nulls, degree has got some nulls, years of study has got some nulls, and educational institution has got some nulls. So we'll try to replace these nulls with some appropriate values. So this is called as imputation. So to extract only the columns which have got nulls, right, what we can do is null dot any has got trues or falses, right? Here, right, the trues or falses are there. If I pass is null dot any, filtering of is null dot any, it will only give you only those key value pairs or the indexes and the values where you have got true. So it is just a filtering, right? On a series object, I applied filter. So you experiment with pandas data frames and series objects, right? You will find better approaches than whatever I am showing here. Okay. So the next thing we wanted to do is how many of the columns which have got nulls are categorical and how many are numerical. Okay. To find out that, right, what I did is I have used this is null dot any and now whatever that whole thing, right, and dot index I said. Let us see what is the outcome of this. Right? The top statement is giving you all the column names with only truths, right? If I say dot index, what is it giving? Only the column names it is giving. To a data frame, if you pass the column names only, right, what you will get? A small data frame you will get, right? Let's see that. So let me do that and let me create a bottom one. And if I say TREIN train set of, right, in a list, if I pass, sorry, it's a list already, so no need to pass. Of the list you pass, you get a data frame. This is a data frame. If you try to look at the type of it, right, it's a data frame. So this is what I did here. In a more what you call it as data frame point of view. I am trying to show these things because if you try to practice this way, you will get more hold on the features provided by data frame and series object, which actually reduces lots of coding effect, boilerplate coding effect. So but this is what I did. So I have got the data frame, and then I said D types. On a data frame, if you say D frame, D types, right? D, the train set dot D types will give you all the columns data types. Only the particular columns which I have got nulls, those data types I have seen. So I have got 3 columns which are categorical and 1 column, 1 feature which is numerical. Okay. So let us try to fix the numerical one first. The years of study is the numerical one. So generally, to try to understand the normal distribution, either you use QQ plot or histogram, quantile to quantile plot or histogram. Just try to see histogram here. So it's a numerical column, that's where we are using histogram. Rather, we would have used a bar chart. Okay. So I have explained that in the previous videos. When I execute this, I don't think this is normal distribution, because if the data is normally distributed, right, the bars would have came like a bell, like that, right? So I think most of the people's experience is between 15 and 16 years. Out of 1500 and odd number of records, around 625 or so are having 15 years of degree. So that is a mode, right? Mode is nothing but the probability mass function, right? Probability mass function of 15 years is more, the value is more than compared to the other values. So like we can take the mode and replace. That's a generalized thing. When most of the people are having 15 years of experience in the office, the ones who were missing the years of experience, right? We can replace that mode value with that. So I am taking the mode value. When I said the mode dot value, it actually gives 16 years. Actually 15 to 16 is 16. So I have got a numpy array here, which is saying array of brackets, right? So we need to actually take the 0th index value in this numpy array. That's nothing but the value 16. So I have taken the years of study impute value, a variable, and then I'm actually capturing the value there. The years of study impute value will have the number 16. And when I try to print that, it's going to have 16. And I replaced it. The fill NA is a method on a series object which actually takes the value and replaces np.nans with this value, the 16. Right? I said in place true. That means it is going to replace the original data frame. Okay. So this is how we do imputation. Statistically, we analyzed the data and then understood that most of the people are having 16 years of experience, 16 years of educational study, years of study, and then we replace the value. One more reason, right? There is a reason for keeping the value in this variable, because when you work on the test set, you need to use these values to replace, because the understanding on train set is better when compared to test set, because train set has got 80% of the data. Whether you take mean, mode or median, it is more generalized, because we are taking a central tendency from more data. So you will use this value and try to replace it in test set. So that's the reason why I have saved the value into a variable. This variable is going to be used in replacing the test set value. So you'll see that. I'll explain that again. So now we imputed years of study and then trying to see whether there are any nulls or not. There are no. When I try to say years of study, value counts, 16 years, 602 people are there, 18 years, 202 people are there, like that. Okay. So this is actually, fix the problem in numerical column. Let us take one categorical column, qualification. The qualification is BSc, MTech, BTech and all those degrees in India. Okay. So we have plotted a bar chart. To plot a bar chart, we need to take the column and then the value counts. Generally, what is value counts? We have seen in the top just now, right? So value counts are like value and the count. So if you say a plot bar chart, right, values will be taken, the values will be taken on the x-axis and counts will be taken on the y-axis. If you see here, graduation is more. As we have replaced with 16, and that's the most of the years of study, and qualification and years of study are related, right? Qualification is BSc or maybe BTech. the years of study is going to be 16. Most of the people are BTech graduates in the data set. So we should replace here also with mode. So I have taken mode, the mode value of the qualification, and extracted the 0, right? If you try to print it, impute value for the qualification, you will get the grad, right? Graduation is the whatever, right? I replaced it. So this way we imputed nulls here. For the next two columns, degree and educational institution, also we are taking mode only, because here we'll do statistical analysis only and try to replace, right? We are not looking into, we are looking into business but not that seriously. So I am replacing, right? I replaced. So now if you see, any nulls are there? No nulls are there. All nulls got fixed, right? That's about fixing nulls on a data set. And in the next session, we'll see how to convert categorical column to numbers. Thank you.